One of the problems with security is that any network can essentially claim any IP address.
Right, okay.
Everybody can say, okay, these are mine, come here. RPKI provides a way to let the rightful holders of IP addresses and AS numbers have a certificate that associates those resources with a key pair. In the early days, people were really... Well,
Yeah.
it's a new thing, right? And if you drop data, that's... if you're involved in the internet business, that's not something you'd like to do. Yes, governments are right to worry about this because, you know, if the internet would go down here in the Netherlands for a day, I don't know how big the loss would be, but it would be enormous. In a way, all of these things that we're doing are patches. Different aspects of it. But together, yes, I think they do make it better. With ASPA, which will build on the same infrastructure as ROA and ROV, we can take that to the next level over the coming years.
BGP security came into the spotlight once again last month as the White House put out a press release detailing its plans for boosting RPKI coverage in the US. RPKI, Resource Public Key Infrastructure, is a first line of defense against a number of security issues internal to the design of BGP, the de facto routing protocol of the Internet. The RIPE NCC plays a special role in RPKI, acting as a Trusted Certification Authority, or CA. CAs issue the certificates that resource holders ultimately use to prove that they're the legitimate holders of specific IP address blocks, or ASNs, and that others can then verify cryptographically. My guest, Tim Bruijnzeels, has been involved in RPKI standards development and software implementation since back in 2008, working at the RIPE NCC, NLnet Labs, and now back at the RIPE NCC again. We talked about how RPKI works, how governments can and have helped in its deployment, and also about the future potential of the infrastructure. I'm Alan Davies, the RIPE Labs editor, and this is the RIPE Labs podcast.
I joined the RIPE NCC in December 2006. From 2008 onwards, I got to be involved in the RPKI project. So it was a new project for us back then. The RIPE NCC wanted to provide RPKI as a service to their members. So I joined, my first IETF was actually in 2008, I think. I looked it up the other day. It was in Dublin. We're going to Dublin again this year. In a better location, I think. Because back then we were all on a golf course outside of the city. Now we're going to be in Dublin Central somewhere.
Nice, okay.
But anyway, back to the content. So I've been working on this for quite a while now. It's like 15 years. In the beginning, it was really learning what the standards were about and implementing them in code as a software engineer. But over the years, I got more involved in standards development as well. Like as I got to know the system better, I developed opinions as well. So I participated in the IETF process to work some of the standards. Back in 2018, I had become a manager by that time in the RIPE NCC, an assistant manager. I was involved with RPKI, not so much on the code level, but more in project management. But I really wanted more of a technical challenge for myself. So I joined NLnet Labs, where I worked as a software developer / project lead, essentially.
Right, okay.
There I worked on Krill, which is a RPKI CA system that is used now by, it's used by NICBR, so the National Internet Registry for Brazil. They initially funded this work as well. It's by now also used by LACNIC, and it's used by a number of organizations that choose to run their own CA system rather than using one of those services provided by their RIR.
Yeah.
And that was a lot of fun to do. So I really got to do in-depth technical work. But I also felt like it's time for me to, do more high-level project work again. It is really fun, but you're also limited by the time that you have to do things yourself. And I wanted to get more involved in project management again and in the IETF process, still do some bits here and there, but mainly research, let's say, or proof of concept work. but let the team do most of the actual implementation.
Nice, okay.
And been doing that now for a year, again, at RIPE NCC, so it's really nice to be back.
It's been a year already.
It's been a year.
Wow.
Well, almost. Well, in January.
Yeah.
A year, so it's close to a year.
So you were working on RPKI at the RIPE NCC from very early in its development then?
Yes.
Really?
Well, to be fair, others had been involved
Yeah.
before I was. Especially APNIC was involved in the initial development of RPKI, but also in our own ranks. We still have Robert Kiselecki here, and he was very busy with this in the early days. So initially, this was done as a research and development initiative.
Right, okay.
So when the time came to make an actual service that our members would use, that's when it came to the department where I worked.
Right.
That's how I got involved as a software engineer.
Obviously, for most people, if we hear about BGP at all, it's in the context of there's been a BGP hijack or there's been a BGP attack. So just to get us on the right foot as we start, what's BGP and why is it so vulnerable?
BGP is the border gateway protocol. It's about how gateways, how border routers in a network connect to other networks. So the internet isn't just a network, it's more like a network of networks. Right? And these networks need to talk to each other. They're not all connected to each and every other network in the world. That would be impossible. But through their neighbors, all these networks are connected to each other eventually. So to figure out where traffic needs to be sent, each network needs to have information about where to send the data for certain IP addresses, prefixes. And the way this works essentially is that each network can say, okay, these are my prefixes. And then they tell all their neighbors about it, or their providers who tell their neighbors, and so on. And then it's kind of like a rumor protocol where you can hear through different channels that certain prefixes are somewhere.
Yeah.
And then each network essentially makes a table of where data packets for specific IP addresses need to be sent to which neighbor do you send them. This is a very robust system because it can actually deal with the fact that certain paths are no longer available, because then information reaches you about alternative paths to reach that destination, and other paths are selected. So it's able to deal with outages of part of the network and work around that. The problem is that, or one of the problems with security is that any network can essentially claim any IP address.
Right, okay.
Everybody can say, okay, these are mine, come here. And there wasn't anything in the protocol to say that you couldn't. It's not only a matter of whether people thought about it at the time. There wasn't really a way at the time that people could think of to prevent this, and that that would also work and be scalable and so on. So fact remains, every network, as they propagate an update, as it's then called, so there's an IP prefix is announced and an update is sent along the path to other ASNs, AS numbers. The actual path can also be modified, for example, for traffic engineering. But you can also change the path because you want to misrepresent it. There's nothing in the protocol that prevents you from doing that.
Okay, so moving on to RPKI then. That's kind of the first line of defense against this.
Yeah, so where RPKI comes in is that RPKI provides a way to let the rightful holders of IP addresses and AS numbers have a certificate that associates those resources with a key pair.
Right, yeah.
Right, and you can learn about all these keys if you validate the RPKI tree. These keys can then be used to make authoritative statements about the resources. And the most important application that we have of RPKI today is ROAs, origin authorizations. So the holder of a prefix can sign a file that says these prefixes may only be originated by a certain AS. And this allows other ASNs in the internet to look at updates that they get and verify that the prefix and origin are actually valid.
Okay.
or not valid,
Yeah.
or, well, in case nobody said anything about them, not found is what it's called then. And this is quite important because, well, most of the issues by far in the in BGP are because of accidents, misconfigurations. I mean, the 3 and the 4 are next to each other. It's easy to make a mistake.
Yeah, sure.
Right. So that happens.
Yeah.
More than we care to admit. So ROAs and root origin validation protect against that.
Right, so you have ROAs and you have ROV. How do network operators actually go about setting these things up?
ROAs are produced in a RPKI Certification Authority. As RIPE NCC, we provide this as a service to our members. So a lot of people have already activated their RPKI Dashboard.
Yeah.
But if people haven't, they can easily do so in the LAR portal.
And that's just members can just get onto the LAR portal and do that. Okay.
Yes. And then the service provided by RIPE NCC takes away essentially all of the burden of having to deal with the details of how certificates work, how ROAs are created and assigned, etc. So what our members then need to do is essentially specify which prefixes they want to be authorized for which AS numbers, and then the system will generate the ROAs for them.
Yeah.
And more than that, we will also look at the information about BGP that we have through the RIS root collectors. So we'll provide our members with suggestions.
Right, okay. Yeah.
And in the end, it's the network operators who really know what is supposed to happen. So we're not going to just do this for them, but we give this information. This is to help people create the correct set of ROAs. So you want to authorize what needs to be authorized. You want to not authorize what should not be authorized, right? But having a good overview of what is seen out there in BGP helps in this process. And this has also been instrumental because the first release that we did in, I think, January 2011 is when the service officially launched.
Yeah.
And the first interface was really just a ROA.
Okay.
Like all the fields that you could put into a ROA, and then the system would make the actual signed object for you. But what people would do is they would come in and they would put something into the system and essentially forget about it. And then this would no longer match what they were doing.
Yeah.
So a lot of effort and later, afterwards went into providing this information about, okay, this is what we see in BGP, this is what we see in ROAs.
Right.
This is not aligned.
Yeah.
Please fix it. And I remember that back in the day, actually Alex Bond was one of the people very heavily involved and calling after people saying, okay, you see all these invalid announcements for you that you probably did not intend. Please check your ROAs and fix them. So then the quality level of ROAs went up.
Good. Yeah.
A lot. Like before that time, you wouldn't be able to use them in validation.
Okay, so as people start actually doing their ROAs properly, then everyone can start doing root origin validation, right?
Yeah. As the quality improves, we got to the point where first adopters were brave enough to say, okay, we're going to use this. We're going to implement root origin validation. So we'll run a RPKI validator. We'll take the feed, give it to our router, and tell our router to just drop announcements that are invalid.
Yeah.
And in as far as the data quality hadn't been fixed before then, this really helped to convince the remaining people that actually dropping you because you created a ROA that said something else on what you're doing.
Sure. Yeah.
So you have two choices now. You can either remove your ROA and not say anything if you're not willing to maintain this, or maintain your ROAs.
Yeah.
And say what you do. And as we can see in the uptake figures, people chose the latter. People fixed their ROAs for the most part. I mean, I'm sure that some people will have gone like, okay, I can't figure this out right now. Let me just remove my ROAs and and be okay for
Right,
now.
okay.
But by and large, what happened is that people did not remove their ROAs, but fixed their ROAs to reflect what they actually want to do. And the quality of ROAs improved even further. It's become more commonplace and more safe for other people
Yeah.
to do validation as well. So in the early days, people were really... Well,
Yeah.
it's a new thing, right? And if you drop data, that's... if you're involved in the internet business, that's not something you'd like to do.
Sure, yeah.
So a lot of people have done logging first of like, what would I, if I were to drop, what would I drop? That kind of analysis. But I think we're past that now. If you look at the today and how well ROAs match what people intend, also because invalids are being dropped,
Yeah.
are being forced to fix it. This is now at a level where it's actually quite safe to use this. So to do the validation side, you need to run a validator. There's at least like 4 or 5 open source validators, some of them more popular than others. You run a validator in your system somewhere, in your network somewhere, and this feed can be, your routers can make a connection to it through a certain protocol that a lot of vendors support. And then in config, it's essentially amounts to, router-dependent, vendor-dependent statements, but something where you can say RPKI invalid, well, then drop it.
So how far do ROAs and ROV actually get you in terms of BGP security?
ROAs and ROV can protect against, misoriginations, but mainly misconfigurations.
Okay.
Not so much malicious attacks. Unless you have a way to detect that somebody actually changed the path.
Right, yeah.
In some cases, you may have information, like a provider AS may know who their customers are and who their customers are, and they may know, okay, we will only accept these ASs.
Okay.
Right. But on the global internet, you would need to have other information.
Yeah.
Like across networks. Like how do you do this across the globe for somebody else's customer? And and that's where another application of RPKI comes in that's being developed at the moment, which is called ASPA, AS Provider Attestations,
Okay.
where a network ASN can actually declare who their provider ASNs are. So based on this information, and the complete algorithm is a bit too complicated to get into, but based on this information, it will become much harder to just change the path because it would not be a plausible path anymore. So root leaks are also addressed by this, which is a different set of problems. But it is to give some insight into like, okay, with ROAS and ROV, we already get a lot of benefit because misconfigurations are, they can cause real outages, real problems.
Yeah.
And most of the incidents are not really people trying to do bad things, but bad things happen. But with ASPA, which will build on the same infrastructure as ROA and ROV, we can take that to the next level over the coming years. So in the coming years, we'll hear more about that.
Yeah.
The documents are really, they're being finalized as we speak, essentially. The last call will probably happen in the next IETF on these standards because most of them have been converging and there's only a few remaining issues.
Yeah.
So as soon as that is done, because we have so much work that has been done already for ROAS and ROV, we can start implementing support for ASPA very quickly as well.
Great. Okay.
But for the moment, it's not something people can use. It's just the next thing that will come.
Interesting. I like that point because it's important to keep in mind that, RPKI isn't just ROAs and ROV, it's a whole infrastructure, right? And there's still yet further ways of securing BGP that can make use of this infrastructure.
Yes.
Okay.
Yeah, for sure. So, indeed, RPKI in itself is a public key infrastructure of certificates and manifest and revocation lists and delegated certificates, etc.
Yeah.
That essentially tie resources to key pairs. And then because it's a tree that can be validated, a validator can discover all these keys and which resources they're associated with. Now, other statements can be published, like ROAs. Future implementations will be ASPA. There's also we could go into that a bit. So there's also BGPsec has been developed as well. So there's a set of standards that allows keys to be published in the RPKI that are associated with an AS number. Can be used by routers. But then routers can sign their updates, they can sign their announcements, and they can verify the signatures of everything they receive. Unfortunately, we haven't seen deployment of this.
Right.
For a number of reasons. So, first of all, it takes pretty advanced routers that are capable of doing this.
Okay.
And one of the strengths of the model with ROAs, which will also be used by ASPA, is that the burden of doing the cryptographic validation and signing is not happening in the router.
Yeah.
So the CA is operated separately. For ROAs, the RIPE NCC provides a member interface where a service where members can configure their ROAs and the actual objects get created, get published. The user doesn't need to do anything about it. Validation software can take this information and validate it. And essentially, at the end, a table comes out of data that has been validated, and that's what is used by the router. So it doesn't have to do any cryptographic calculations and whatnot. So even on modest hardware, you can do ROAs and ROV. Whereas with BGPsec, that's more of a challenge. And maybe one day we'll get there.
Yeah.
So as RIPE NCC, we're actually also planning to start supporting the creation of BGPsec router certificates through the in our interface, or through our API to begin with.
Okay.
But a lot of work needs to be done on the router implementation side.
Okay.
But yeah.
Yeah, maybe.
Okay, so that's not something that people can use today in the network, at least not at scale. But it is an example of how the RPKI is essentially the infrastructure. ROAS is a specific implementation around root origin validation. BGPsec is a way to make sure that the messages in BGP cannot be forged, essentially, or well, you could see that the signature doesn't match.
Yeah.
Right, so you can be sure that there's no lies in the path. ASPA kind of takes a different approach. It is also involved with the path, but it doesn't actually secure the messages in the path themselves.
Okay.
But it, in the end, it provides a table of plausible AS to AS hops that can be used by a router to then determine that a path is actually a plausible path.
Right, okay.
So you don't have the full certainty that you would get in BGPsec that, this is the exact path. But you would get a good indication of whether this is a path that is plausibly intended. And for a lot of the cases, that is good enough.
Yeah.
And in a way, it's actually also complementary to BGPsec, because what you can do in ASPA is there can be a relationship between ASs where they can exchange messages, but you don't expect them to be propagated onwards, like root leaks, for example. I send my routes to you, but you're not supposed to send them somewhere else. And if you did, then ASPA would catch this. Whereas BGPsec would just go like, okay, yeah, we both signed this, and it's okay, it happened.
Right, okay.
Right, so it's addressing a slightly different problem.
Yeah. The way that you approach the topic and you talk about the topic, you're very much, in the actual implementation of this. But then, outside, we're all hearing this news from the White House, and the US is now making a big push for better BGP security. What is it now that's really causing governments to take action, would you say?
I can't really speak for a government.
Yeah.
if I put myself in their shoes, that the internet is of vital importance to the economy and national security as well. So disruptions of the internet can have a huge impact on our society. So yes, governments are right to worry about this, because if the internet would go down here in the Netherlands for a day, I don't know how big the loss would be, but it would be enormous. And the same goes for any country. Right? And so I think they are concerned, and I think to a large degree they've also been quite happy for the bottom-up process in the internet community to work. People are working on the standards, are being developed, and I remember that actually the US government in particular, they were also involved in funding some of the work that went into the IETF to develop these standards.
Right, okay.
So they were quite involved, but they were not so actively pushing, so to say, the organizations within our legislation to use this. So initially, they were facilitating, making sure that these standards get developed, that researchers could work on developing these standards, and so on. In the Netherlands, we actually have something similar. I mean, at a much smaller scale, of course, much smaller country, but we have a directive that would translate to something like apply or explain.
Okay.
That applies here, pas toe of leg uit in Dutch, where at least governmental or semi-governmental organizations are required to either use ROAs and ROV or explain why not.
Okay.
That doesn't make it mandatory to apply, but at least it increases the awareness of, you should be thinking about this, really. And it would be good if you did this.
Yeah.
And I think in the US they're now going a bit further than that. Ultimately, the configuration of routers and exceptions and whatnot, it's still always in the hands of the network operator. So whatever the RPKI says, you can also make your local changes. So I think what the US government is really doing now is pushing for best practices.
Right. We talked in other episodes about how government pressure can sometimes put quite unwelcome stress on the technical community. But this doesn't seem to be that kind of case.
In the early days, when we talked about RPKI, this was one of the concerns that was brought up. So like, what if governments want to come in and make changes in RPKI? Well, in theory they could, but I think it would be very much against their own interest.
Yeah.
Because it is a very crude tool to if, for example, you would want to block a website.
Yeah.
Then doing it this way it's quite ineffective. People can still have exception lists, for example. Plus, you can only block a complete network. But more importantly, it would also really undermine the trust in the system.
Yeah.
Which is something you really don't want. And if people don't trust the system anymore, then your police service, your hospitals, your all the things that you, as a nation, you should want to protect, are no longer protected.
Yeah. Okay.
Effectively, right. So I think it would be very much against government's interest to try and do this kind of thing.
Yeah.
Unfortunately, I haven't seen them try to do this actively. That would be a concern. Yeah.
Yeah.
But the idea of promoting organizations to use this technology, I think that's a good idea.
Nice. Okay, so there is an alignment of interest and approach here. One of the big problems for the US in pushing RPKI coverage just seems to revolve around the sheer number and diversity of networks that they need to cover. And we've actually seen the suggestion in work on RIPE Labs and in other places that sometimes if the big networks do RPKI, they can help protect the smaller networks. Is there something like that built into RPKI that maybe not everybody needs to do it?
So I think the uptake in terms of ROAs, of networks declaring what their intentions are, that's already, well, fairly high in some places and growing in other places. And that's where small networks really also have a role to play. Like they need to declare where their IP prefixes are supposed to be originated.
Yeah.
Right. But if we look at the validation side, then smaller networks, well, they can protect themselves if they have multiple upstreams, and then they get routes from different through different channels. Then they can also do root origin validation. And, that way, choose a correct path. But if bigger networks do this, like the providers that have many customer ASNs below them, or even transit networks would do it, then that really prevents a lot of the root origin validation invalids to reach the rest of the internet. So if these big networks do the validation side of it, that will really help effectively protect a lot of the other networks, even if they don't do active validations themselves.
Cool, okay.
That being said, it's always good to do your own validation, especially if you have multiple networks. Like if you only have one provider and that's where all your routes come from, then you can still do your own validation, and you can drop a route that you believe is invalid, but then you have no way to reach that destination anymore.
Yeah.
Which can be a feature at that point, but you don't get the choice, right? So if this happens further up, more where the big networks are, that also improves the chances of the correct routes to actually reach those networks.
Okay.
So yes, validation is something that really should happen.
Okay.
In the bigger networks.
Interesting, but establishing those ROAs, making that claim that this prefix should come from this network, that's really for every network operator to take responsibility for.
Yes.
Okay. Good. Okay, nice. And then maybe then we could touch on. I was thinking, kind of, back at the RIPE NCC now. What's the focus for you in your day-to-day work in making this easier for the average RIPE NCC member? How do you?
Yes. So, well, we've been working on a new version of the RPKI Dashboard because the current version is quite some years old.
Okay.
I think I may have even done some coding on it back in my days.
Right. Okay.
Which is about like 8-9 years.
Yeah.
Well, there's two sides to this. So there's a technical side, which is that the front end libraries and technology that we're using is aging, so we need to replace it. But also we found that the usability could be improved. So now we're building a new dashboard that we're launching very soon. So we're starting beta testing in the coming weeks, actually, and we hope that we can deploy this new version before the RIPE meeting even, but we won't rush it. We want to be sure that everything is okay. And take our time. Yeah. So I won't promise it, but it's coming real soon now. And what this will do is that essentially it makes the flow of creating ROAs better.
Right.
Because something we didn't touch on is that in some cases, when you create a ROA to authorize one announcement that you do, that announcement can actually make that ROA can actually make another announcement that you do invalid.
Right. Okay.
So you need to have a complete overview, and there's cases where you need to make multiple changes in one go and apply them all together. This is also in our current interface, but the way this is done is that our current interface always makes you follow this flow. And if you make a change, essentially you get a little red icon at the bottom of your screen saying, okay, you have pending changes. Do you wish to apply them? But it's not very clear to some users, that this is what needs to be done. So people do the first step and then they go away
thinking that they created a ROA and they haven't.
Right.
So we're making some of that a lot more explicit now. Also, we provide an alerting email service, so people can subscribe and get emails if we see new announcements for them for their space that would be invalid or not covered by ROAs. And this was also kind of hidden in the old interface. So we're trying to improve the user experience by making these services more apparent and more easy to use. This work will also allow us to easily build in new object types. So new RPKI developments will be able to incorporate this in this user interface more easily.
And this is the thing you were mentioning back at the start. What's it called again?
Yes,
I keep forgetting the ASPA. Yeah.
Yeah. So as soon as we see that the IETF reaches consensus on ASPA, the profile and the validation and everything, which is very close, we're well positioned to start offering that in our user interface as well.
Okay.
And then our members will just be able to say, okay, as the holder of this AS number, I can declare that these are the providers that people can see for me on the internet.
How do you feel as an engineer about like the outlook for BGP? Is it still this massive vulnerability, or are we closing the gap on that?
It's. I think we're making progress, but it's a lot of work. I'm stealing somebody else's comparison right now, but it's like, changing the wheels in the car while it's running. It's not entirely that, but we're dealing with, the internet is there. It's being used. You can't just fundamentally change it overnight. Things take time. So, in a way, all of these things that we're doing are patches. Different aspects of it. But together, yes, I think they do make it better. And I don't think there's any other way to do this. Like, I don't think we can just redesign the way that, BGP works from scratch and then expect it to go somewhere. We have to deal with this reality.
Yeah.
So, in that sense, sometimes ROAs, ROV are criticized for not being a complete solution. And I think, well, yeah, okay, but you have to start somewhere, right? But this is one thing. Then ASPA will patch another thing. Then maybe someday BGPsec will be more deployable. As a model, I think, BGP has proven to really work. It's a robust system. It's been, it's proving its worth.
Yeah.
And I think RPKI also proves that, we can actually at scale have reliable statements about the use of IP addresses, ASNs, on the internet. ROA ROV is connecting that. I think ASPA will take us to the next level.
Yeah.
I don't know what will happen after that, but I think there will be more applications of RPKI, maybe even outside of routing, where it is useful to have the holder of a IP prefix or AS number say something about their resource.
Thanks very much for talking to us. The napkin story didn't get in there. That's our episode for this month. Please, as always, if you liked what you heard, remember to subscribe and share. We'll see